were on estrogen. What did we know back then on this important hormone? And today?
Yeah. Well, it's interesting because compared to today, we know very little. When I started in the field, as I mentioned before, the concept of receptors was even strange.
Yes.
And today, what do we know? Oh my goodness! You know, where do I begin? We know so much about it. You know, we know about the receptors, we know about transcription factors, we know about signaling pathways. You know,
but we don't know about all the different forms of estrogens.
Oh, the different well, you know, that was one reason why I got out of the field of estrogens, is it was getting too complex. So what do? I go into prolactin, which is even more complex because, and it's not a simple molecule, but it's a peptide. Absolutely. And of course, you know, so, and in terms of jumping ahead a little bit, I think when you asked about prolactin, what did we know back then? When I joined Yale Topper's lab, Henry Friesen had just the year before published a paper proving that human prolactin existed. And back in the early 70s, they said, no, humans don't need prolactin because they have growth hormone and it acts as both lactogen and a somatogen. And so, and now we knew there was a human prolactin, and Yale's lab was studying milk production using whole organ or explant cultures. And so
already back then.
Back then, explant cultures. And that's the project I took over. I found prolactin fascinating. Absolutely. And you know, and understood it didn't act alone, and that there were a lot of other things involved, and there were probably receptors. In my mind, being a receptorologist, I said, you know, I am going to work on that receptor. That's what I'm going to do.
So that's how you started with the prolactin.
When I started my own lab,
So you were interested in aspects of proliferation versus differentiation of mammary epithelial cells. Can you tell us more about this?
Well, you know, this is really fascinating because prolactin is involved in both proliferation and differentiation. And because for years milk was the thing that was studied in the end, and that's what prolactin did, the proliferative side of prolactin was totally ignored. And to this day, many people in the field still think that the way prolactin acts to cause differentiation is the way it does, you know, for differentiation is the way it works for proliferation. And I have always said, no, I do not believe that. It can't be. It just can't be. And, you know, the first paper that we submitted showing that prolactin-activated MAP kinase was rejected because, and this is a direct quote, everybody knows that prolactin acts through STAT5. That's it. They're wrong, is what it says. This paper is wrong. Everyone knows that prolactin acts through STAT5. Well, we submitted it someplace else, and I wrote a paragraph to that first person that said, we're submitting someplace else, but I want you to know that everyone doesn't know that, and those who think that's true are wrong. And I think with time, I have been proven correctly. I think STAT5 is involved in proliferation, but, you know, all those other signaling pathways too, and, you know, all of this just...
Absolutely.
Yeah, so, and we all know that.
Yes.
Yeah,
so in 1975, you wrote on techniques for studying development of normal mammary epithelial cells in organ culture. What did you learn about this over the years, studying organ cultures? Because that was also the time when people were using cells and dissociated cells.
Yeah, it's interesting because I used explant culture, and this was, when they said organ culture in this particular paper, it was explant.
Absolutely.
But then Mihir Banerjee and his group perfected a system that was started in Nandy's group on whole organ culture, and so I've done both. And I remember giving a lecture here to the medicine branch here at NIH on some of the work that we've done using explant cultures and showing, I think it was some of the thyroid hormone work that we did, thyroid, insulin, prolactin, insulin, hydrocortisone, prolactin, and if you add thyroid hormone to that, you know, you get an enhanced differentiation. And so I was presenting all of this, and when I get done, the first question I was asked, and I shouldn't name names, but Mark Lippman said to me, he was here at the time, he said, "Why are you doing this? Why don't you just use something like a single, cell culture like an MCF7 cell?" And that's what everybody was using at that time. And my answer was, I do this because the mammary gland is not just epithelial cells, and we need to keep as much of the organ intact as possible so that we get those interactions. And that's why I use organ culture and I use explant and whole organ culture. And I think MCF7 cells don't tell us very much about the normal mammary gland, and that's what I'm interested in at this point. Okay?
Yes. So your first paper with Gilsmith and Jeff Rosen, whom we interviewed or we are going to interview, was published in Cancer Research in 1978, and the title was A Difference Between Mammary Epithelial Cells from Mature Virgin and Primiparous Mice. So 35 years later, this is still a very exciting topic of research, especially the question of what mediates protective effect of an early pregnancy. Isn't that amazing?
And the answer is yes. Yes, it is. It really is amazing. And it's something that, I've always been curious about. And I think it's still an open question. And I served on the Avon Breast Cancer Board for quite a few years. And I proposed to them that they set up a group of grants to study this very question. And they did. And several people that I know got some of the grant money to study why early pregnancy is protective. And it's just ongoing, it's very interesting, and what can I say? Except that I wish everybody out there good luck, because it's a question I'd love to know the answer to. Yeah.
So in the early 80s, you started working on cancer.
Mm-hmm.
What triggered this interest? Is it the melanoma?
Yes, I always knew that that's where I wanted to go. That's where I wanted to be, is in cancer research. And the opportunity came up to join the Cancer Institute, and I jumped at it. And since I've been studying hormones in the breast, it was just obvious where I'd be. Yeah, and yes, my brother influenced me very much.
So, with all the knowledge that we have today, what are the links then between estrogen, progesterone, and prolactin in cancer?
Well, I call them the big three.
Oh, I remember hearing you saying this at the
and when I gave the talk at the Thursday night talk,
absolutely.
I had a diagram and I show how throughout normal development and how they interact and they regulate each other in terms of the hormone production and release and synthesis. They regulate each other's receptors, and it's just this wiring system of, and you change one, you change the others, and that's why I always persisted, and it'll jump ahead to one of the questions you're going to ask about prolactin, the forgotten hormone. I always said, we know estrogen's involved, we know progesterone's involved, why wouldn't prolactin be involved?
Yes.
It was just silly to eliminate it.
That.
Yeah,
absolutely.
and it was ignored for a long time, but it is definitely not ignored anymore.
Sure.
Yeah.
So later you continued to work on prolactin in the normal and neoplastic breast.
Mm-hmm.
But why prolactin?
Well, first of all, it was just kind of the normal evolution of things, but also I guess I've always been for the underdog. and people were ignoring prolactin, and I didn't think it was right, and I thought it was being scientifically narrow-minded.
And you, as you said, you thought that there are so many estrogens.
It was too complicated. So of course, now we know that there are all kinds of prolactin receptors and homo and heterodimers and signaling pathways, and it's like,
it's definitely fascinating field today. So the mammary gland also secretes prolactin. So what are the implications of that for cancer? Do cancer cells also overexpress prolactin? I think it's the case, right?
Yes. Actually, Erica Ginsberg, my technical lab manager, and at the same time, Chuck Clevenger, who's at Northwestern now, he also was approaching that question of, does the mammary gland and do cancer cells make prolactin?
Yes.
And the answer is yes, absolutely. We know so little about autocrine prolactin, though. You know, how it's regulated, where it acts. Is it only autocrine, or does it actually get into the bloodstream? And my contention is that breast cancer cells, of course, the ones we study in culture, were all derived and grown without prolactin, so we selected for ones that weren't prolactin dependent. But there are some that are prolactin responsive, and we know that some of them, like the T47D cell, makes a lot of prolactin. And I think that was the breakthrough for people to start realizing prolactin might be important in breast cancer, when we showed not only that there was message there, there were people that had shown dabblings of message in the mammary gland, but we were the first to show that there was actually active protein made, and that the T47D cells made a bucket of it. And so I think that opened people's minds, because it explained why there could be no clinical response if you blocked pituitary prolactin in a patient, or removed pituitary, because if the breast cancer cells didn't have circulating endocrine prolactin, they would make what they needed, and they did. So, and that was a great.
If I recall well, I think something in the bovine serum interferes with prolactin. Is that? Can you remember?
No, I remember that paper. In fact, I was giving a poster at the AACR meetings many years after we published that, and some guy came up and said, you know what, there's this fascinating paper in low literature that shows that in fetal calf serum, there's something, and it's bovine prolactin, that inhibits the action. And I said, I know, that's my paper. So, and that's never been followed up, but I think there are some kind of clues out there because of the work of Amia Walker, where she has this derivative of prolactin that's actually it shifts from differentiation to proliferation, and also some of the derivatives that are being made that are used as blocks of prolactin. So I think bovine prolactin probably has enough conformational differences or something that it just inhibits human prolactin or ovine prolactin from interacting with the receptors.
One of the reasons why we select for cell lines
that are independent of prolactin, because you grow them in the presence of fetal calf serum. But you can remove that by charcoal stripping your serum. You don't just remove steroids. You remove
the same way. In 1998, you wrote an article with the title "Prolactin, the Forgotten Hormone of Human Breast Cancer." I guess today it's not forgotten.
In fact, Novartis has an anti-prolactin receptor antibody in clinical trials.
So that's
good news.
Yes,
I'm very excited about that.
So after all these years of studies on prolactin, what else needs to be known on this important hormone? What do you think? So of course, clinical trials are ongoing in terms of cancer, but I'm sure there are several aspects of this hormone that we still ignore.
Well, what we need to know is the function of the different isoforms of the prolactin receptor, both as hetero and homodimers, and how they differentially might affect differentiation as opposed to proliferation. And we need to know if they act the same in the normal gland as in a cancer's cells. And that's a huge,
of course, program.
It sounds simple, but it's huge.
Absolutely. And of course, differences between the endocrine prolactin
and autocrine
are
prolactin.
they signaled the same way?
Exactly. We need to know all of that. And people are working on it, and I wish them all kinds of luck. And I do keep enough of an ear to the ground to know that, like I said, I don't prolifically read the literature.
So you mentored many students and postdocs. How important was this for you?
It kept my lab alive. I used to tell the postdocs and the people in the lab that the reason I brought in so many young students into the lab was for our sake of us. We would you get into ruts where you use scientific flip language and and stuff, and you just do things without thinking about it anymore. And if you have a student in the lab, an undergraduate or a postbac or something like that, and they say, well, why do you do that? It's like, whoa, well, because I've always done it that way. No, you got to answer those questions.
Absolutely.
Yeah, and so, plus, there's an old Chinese saying that I had on a plaque by my desk that said, if you want to feed a man for a day,
give him a fish.
Yeah, give him a fish. If you want to teach him to fish, that
He
that whole
can
thing.
feed himself.
Yeah, something like that. Yeah, it wasn't the feeding, but anyhow, and the whole thing is, teach them.
Yeah.
Teach them if you want them to survive.
So you remind me of a saying by French philosopher Michel Montaigne, saying that teaching is not about filling a vase, it's about igniting fires.
Exactly. And if I was able at some point to take a student who was wondering whether or not they should go be an artist, or in my case, I was thinking about journalism actually, to be a journalist. Being a journalist or being a chemist, could I push them to chemistry by my mentoring, if you will? So I firmly believe in that.
So Barbara, what would you advise a junior faculty who is going to start her or his lab on mammary gland development and breast cancer?
Yeah, stick in there. I think, I'm going to talk here. Things are really tight right now in terms of money. I know that. Grants are horrible to get. And here at NIH, too, people are being cut and their programs cut and stuff. And over my nearly 40 years here at NIH, I saw ups and downs, hard times, better times, etc. This will pass. It may not be the glory days of, the first throwing money at science and stuff, and maybe this will get us thinking more strategically how we use the money, but it will get better. It will get better. So you need to hang in there.
Never give up.
Never give up, because if you have the fire in your belly, you got to do science.
Yes,
you just
absolutely.
got to do it. But another piece of advice, just real quick, is a lot of times you're the only mammary gland biologist in your department or in your university. It's important to network, and that's why going to meetings like the Mammary Gordon Conference is extremely important. And you shouldn't hesitate to contact senior people in the field and just say, I read your paper, I think this is fascinating. Could you help me? How do I do this better? Or I'd like to learn this technique, but I don't have the money to come to your laboratory and learn it. Well, they may have money to bring you there. Give a seminar and spend a day, something like that.
And I think there is
reach out.
There is something unique to our mammary gland Gordon conference. I remember one of the first or second one I attended. Jeff Rosen just came and sat and stuff. Oh, hi, I'm Jeff Rosen. Of course, I said, I know you are Jeff. And the same thing happened with many other key figures in our field. They would just come spontaneously and sit and talk with you. Are you a PhD student? Are you a postdoc? And I think this is
that's what Gordon conferences are all about. And I because I was on the board and chair of the board and stuff, I've attended about 50 Gordon conferences, or more than 50 in my career. Not all of which are mammary gland. All kinds of conferences, and the mammary gland is very unique. The group. A lot of the other groups, the senior people sit here, the junior people sit here. They never interact. And in the mammary group,
absolutely
tremendous mixing.
I think I went to the first one in 2002, and since then I went to every single one, and I'm sure I will go to all the others. So, what are the major questions that you think still need to be answered in the field of mammary gland development and cancer?
I will tell you two areas, and I told Jeff Wall this several years ago, and he followed up on it, which I thought was beautiful. Is if I were starting over again, I would be studying the embryonic mammary gland. That's an area where we have...
He did some fascinating
work.
work.
He did beautiful work.
Absolutely.
And there are other people working on it, and I think right now it is in wonderful hands, the embryonic. So what would be the other area that I would really do is the normal human breast. We need to know so much more about the normal human breast. And Jody Fleming, who was in my lab, did some beautiful work on the normal human breast. And we addressed the question of why do African Americans get breast cancer that is more aggressive, more ER negatives versus ER positives? Not by looking at the tumors, because you can only get so much information at the end. What we did is we went back and looked at the normal breast, and we found that there were very systemic differences in the composition of African American versus Caucasian breast. And I think that's a rich area that just, and I realize getting tissue is a problem and all that stuff, but it is doable. So,
Thank you. So, Barbara, one of the last questions. What would you like to tell the next generation of scientists who will watch this video? Please.
Well, I think I kind of already said, just hang in there. If you have the fire in the belly to do it, do it. Make it happen. And use the resources that are out there. The senior people in this field are fabulous. And if they don't know the answer, they can help you find it. They'll tell you who does. Oh, I don't know that, but listen, call so-and-so. Or let me call so-and-so and introduce you. You know, that happens all the time.
Yes, I can witness. It happened to me many times.
Yes.
You know, when we were starting the lab and looking for the protocols, we didn't want to reinvent the wheel.
Absolutely.
So I just sent emails.
Yeah.
And then I got so many answers. I ended up with more protocols than I could even try. So this is absolutely true.
Yeah, it's great.
Thank you, Barbara. Is there a question that I should have asked and I didn't?
There is retirement at the end of all of this. And that's another little piece of advice, though, before I forget. And I did learn this from Anita Roberts. There's got to be more to your life than the lab.
Thank you very much. Thank you, Barbara. It was a pleasure.
Thank you.